Alright guys, example 1 and 2 took a little while to do. I didn't think it would take that long, but I just emphasized a lot on finding the domain, so once again please understand how to do that. Let's move on, and maybe this will go a little bit quicker, these next ones. So if you understand domain, you should be okay. So just look at a word problem here. For a white rhino, heart rate R, beats per minute, and the lifespan in minutes are related to the body mass and by these functions. Okay, so the R means the heart rate, S of M means the lifespan, and it wants you to, it's about talking about M, the body mass. So it says find R of M times S of M. So just take this times this, R of M times S of M, and then explain what it represents. So to do that, you guys know to substitute right there. There's R, there's S. Put those together. Take 241, times it by 6 times 10 to the 6th. Get a number. Take M to this exponent times M to this exponent. M times N. Add up the exponents. Get a number. So what is 241 times 6 times 10 to the 6th? They don't have that for you. Well, it shows it to you right beside each other. Multiply these, then multiply the m's, which means you add up the exponents and get. Here's your first answer that you get. But notice this is not scientific notation. So remember, it has to be 1.446. So we moved the decimal place. What? And if I put it here, moved it 3 times to the left, which becomes 10 to the 9th power. And then there's your final answer for part 1. What is R of M times S of M? There it is. Now what does that mean? Well, R of M means what? The heart rate times the lifespan. How many years you live, basically. How long you live. So what does that mean if I took how much heart rate you have, how many beats per minute, I think it said, times your lifespan? What do you guys think that would mean? Well, mean this. Multiply the heart rate by lifespan gives you the total number of heartbeats for a white rhino over its entire lifetime. There you go. Example 3, the word problem. Not too bad. Some guided practice. Let's look at this for a second, because this is a little bit different. It's x to the 2/3. So pay attention when you have an even index right here. Pay attention when you have an odd index. Even index, most of the time you can't have negative numbers. Okay, odd index, what could you have? Well, let's just look at this. F plus G, so this plus this, you all can do that. That's easy, right? Put them together. Negative or positive 5 x to the 2/3. F minus G, so take negative 2 of these minus 7 of these gives you negative 9 x to the 2/3. But here's the hard part, which isn't too hard in this case, but it's tricky because people just make this one harder than it really is. So what is the domain of those two things? What is the domain of F plus G? Well, look at them individually. What's the domain of this thing right here? X to the 2/3. Off to the side of me. Okay, x to the 2/3 is, that's the cube root of x squared. What couldn't x be? Could x be positive? Yes. The cube root of positive number? Yes. Could x be 0? The cube root of 0? Yes. Could x be negative in this case? The cube root of negative 8 squared. Yeah, cube root of negative 8 is negative 2. Square that, your answer would be 4. But could you get negative x's? Yes, you can. So really, all reals is the domain of this one. What about this one? This in this case would be the same thing. All real. Put them both together, you still get, in the end, the domain of this particular problem would be all real numbers. Okay? What about F minus G? Domain of this one is all real. Domain of this one was all real. Even when you do that, it still becomes all real. Your domain is all real numbers. Okay? So, remember the last problem, it was like x to the 1/4. This could not be negative. X could not be negative, which means the domain of this one is x is greater than or equal to 0 domain. Just for this thing right here. Okay? Side note. Alright, there you go. We did that. All real, all real. Okay. Gotta practice for this one. Actually, just do this quick. F times G. Everybody can multiply and everybody can divide, but the hard part is doing the domain. So, multiply. What do you get? This times this gives you 3. X times x to the 1/5 gives you x to the, what's that? 1 plus 1/5 is 6/5. What's the, let's just do the domain right now. What's the domain of this thing right here? Once again, look in the original. What's the domain of this one? All real numbers. X can be anything. What's the domain of x to the 1/5? Meaning this, 5th root of x. What's the domain? Could x be positive? Yes. Could x be 0? Yes. Could x be negative in this case? The 5th root of a negative number? Yes, it can. So actually, all reals make the domain actually all reals in this case. The question didn't ask that yet, but I'm doing it right now. And the last one, you always got to pay attention to when it's division. It's a little bit trickier. F of x, 3x, g of x, x to the 1/5. If you divide these two, you get 3. X at first minus 1 minus 1/5 is 4/5. 3x to the 4/5 power. Now, if I look at this, that's like 3 5th root of x to the 4th power. So x at 4/5 is here. What could x not be? X could be 0. X could be positive. X actually could be negative. Why? Because the index is odd. X could be negative. That means in this, if you were just looking at this, it's actually all real numbers. But if you go back to the original, which I keep telling you to do, what can't x be down here? The denominator cannot equal 0. So if x was 0, the denominator would be 0. You cannot divide by 0. Okay? So this answer is a little bit, you have to say this, all real except 0. Alright, so sometimes you have to make exceptions. Why can't it be 0? Again, you can't have 0 down in the denominator. That's why. Okay, that's it. It's enough practice. Example 4. Notice the answers to those two things. All real, which we said, all real except 0. Alright. Let's get to example 4. This is called composition of functions right here. What we're going to do is we're going to compose two functions. Look at this notation right here. Yeah, I should go backwards and show you some notation. You might have seen this before. There's a few things you got to know under composition. Here's one. If you see this, this means f of g of x. If you said it in words, it would be this: f of g of x. Okay? It also could be written like this: f circle g. F of g of x, f of g. You could see these two things, but in all cases, it means f of g of x. We're putting together g of x and f of x in the same thing. We're composing. Okay? Putting them together. Now, what does this mean? Or I could write it like this: g of f of x, which means in words g of f of x. Another way to write it would be g of f. Okay, same thing, just different ways to write it. Okay. Let's go do composition. What does it mean to compose? Put one inside the other, basically. Okay, so when you see this, alright, let's do the easy one first. Let's do G, so it means G of F of 3. Here's what you do first. You do the inside first. F of 3. What is F of 3? Everybody can do that, right? What does it mean to be? What does F of 3 mean? Plug 3 into F, right? Look, here's F of X. All we're going to do is plug 3 into here. Okay, so 2 times x minus 7. That's what F of X is. We're going to plug 3 in because that's what it says. So 2 times 3 minus 7. So what do we get? We got 6 minus 7 equals negative 1. So what we got here was F of 3 is equal to negative 1. Why do we need to know that? Because we got to put that right up here. F of 3 we found to be negative 1. So what do we have now? We have G of no longer F of 3, but F of 3 was negative 1. I'm just substituting. So now look what we have to find. We got to find G of negative 1. So we go up to G, which is here. All we got to do is put in negative 1 into the equation, or into the expression here. So G of negative 1, well, G of X equals X squared plus 4. So G of negative 1 means replace negative 1 squared plus 4, which negative 1 squared is 1 plus 4 gives me 5. There you go. G of negative 1 equals 5. So G of F of 3, all this together, composition, is equal to 5. Here you go. There's example 4. Just finding something like this. But I don't want to just find just one answer. I want to find G of F of X. So let's go on to the next one here. Alright, here's the last example we're going to do. Example number 6. The word problem, I'm just going to skip that. So let's just do composition of functions. This is another key problem. So key things in this section are be able to find domain, whether if it's dividing, multiplying, adding, subtracting, and be able to do composition. And then we're actually going to do domain with composition as well. You're going to find the composition of these two things and then find the domain, which is actually still tricky. So here we go. Let's do composing. Find the following. This means F of G of X. Okay? Now all you're going to do is, see this G of X right here? You're going to replace it with what G of X is. So G of X is 5x minus 2. So you're going to put this wherever you see G of X. So you're going to replace this right here. That's what they're going to do. Watch. See, they put it in red. So G of X is 5x minus 2. See how they replaced it? Replace G of X with 5x minus 2. Now, what you're going to find now is F of 5x minus 2. Some people think, well, what does that mean, F of 5x minus 2? Well, if I said, hey, find F of 2, what would you do? You would take this 2 and you would plug it into F, right? So you would take that 2 and you'd look at F and you'd say, oh, put 2 right there. Well, that's the same thing I'm about to do here. Okay, you're going to take this, whatever this is in parentheses, and you're going to plug this into F. You're going to take this and put it into wherever you see X up here. So that's why they write this. 4 times this used to be X to the negative 1, right? See up here? 4x to the negative 1. 4x to the negative 1 power. Okay, that's the easy part, substituting. Now, how do you do this? Well, this has a negative 1 power. So what do you do with a negative 1 power? You flip it to the bottom, right? Negative 1, so it's 4 on top times 1 over 5x minus 2. Okay, they just flip this to the bottom. There you go. Now it's 5x minus 2 to the positive 1, which that's all it is. There you go. This you cannot simplify anymore, so you're good. Check. What is this right here? This is composing f of g of x. Let's do another one. Let's do g of f of x. So it's different. It looks the same but different. So what do you do first? Well, you go and find f of x. There it is. And you're going to replace f of x with what it is right there. So that's step number one. So they replaced it. Instead of f of x, they put 4x to the negative 1. Now all you're going to do now, if I said, well, hey, what's g of 2? You would put 2 into g. You'd go up to g, put 2 in there. Same thing here. You're going to put 4x to the negative 1 into g. So go up here to g, and wherever you see an x, you're going to put 4x to the negative 1. Okay? So let's replace. That's why they have 5, and that's supposed to be 4x to the negative 1. That looks like x minus 1. That should be an exponent of 1 up here. Okay? 4x to the negative 1 minus 2. See, all they did was take that x and replace it with what they told you to replace it with right here. There you go. 5 times 4x to the negative 1. Let's rewrite that. 4x to the negative 1 minus 2. We can multiply 5 and 4 together and get 20. X negative 1 minus 2. X negative 1. We're going to flip that. We're going to put x on the bottom row, right? So 20 on top. X flipped to the bottom to the positive 1 minus 2. There you go. That's all you can do with that. You can't simplify that. That's it. Here's the answer to g of f. Okay, you got f of g was equal to this. You got g of f equal to this. Circle that, star that. Now we're going to have to find domain of those things. Okay. Actually, the last one they did f of f. You can do that. You can do a bunch of things. F of x. So let's replace f of x with what it was. I believe it was 4x to the negative 1. So we got f of, this was 4x to the negative 1 power. Okay, now all we're going to do is we're going to plug in this. I'll write this up here. F of x, 4x negative 1. We're going to plug this into the f. Okay, which you're going to plug it into itself, basically. So we're going to plug this into right here. So we get 4. This is confusing, but it was f of x was 4x to the negative 1. Well, we're going to replace x with what it told us. If that was a 2 right there, you'd put 2 right here, right? So this is 4x to the negative 1. I'm going to put it here. 4x negative 1. And all I'm going to do now is simplify this thing right here. So this equals 4, let's see, times, and you got to do the exponent first. This to the negative 1 power. So 4 to the negative 1, which is 1 over 4 to the positive 1. And then this to this is really just times x. So 4 times 1/4 is, cancels out, that's 1, that's x. There you go. You found f of x. Okay. Now, last one. Find the domain. Let's go back. F of g, our answer was this right here. The hard part of this is write down domain, star it. This is what people miss right here. The domain of f of g. The first thing you have to look at the first. You have to look at the setup, basically. Okay, right here. You can look at f. You can look at g. What is the domain of f? Now, 4x to the negative 1 means 4 over x to the 1. What can't happen here? X cannot equal what? X can't equal 0. X could be negative, X could be positive, but X can't be 0. Okay, keep that in mind. Over here, what could or could not X be? So 5X minus 2. Could X be 0? Yeah. 0 minus 2, negative 2. Could X be positive? Yes. Could X be negative in this case? Yeah. 5 times negative 3 minus 2. Yeah, you get a real answer. So in this case, it's all real numbers. Just for this case. Just for this case, it's X cannot equal 0, which means all real except 0. Here's your domain right here. All real except 0, all real numbers. So far, just based on those two, basically you could say the domain with these two is all real except 0. But there's one more thing. You have to check the end result. So when you find domain, check, here's what you have to do. Check individual domains. Like, check this domain, here it is. Check this domain, here it is. And then check your domain of your result, which is this guy. What is the domain of this? Well, could X be positive? Yeah, could X be, like, put a number in there. Could X be positive? 3. Could X be 3? 5 times 3 is 15 minus 2. Yeah, so you'd have 4 over 13. Good. Could X be negative? Put in negative 3. 4 over 5 times negative 3, negative 15 minus 2. Yeah, you'd have 4 over negative 17. Yeah. Could X be 0 here? 5 times 0 minus 2. So what do you get? 4 divided by 0 minus 2 is negative 2. You do get an answer to this. But you have to pay attention to one thing. The denominator cannot equal 0, right? Right, we can't divide by 0. Denominator can't be 0. Well, what would make this denominator equal to 0? So you have to ask yourself that question. Start. What X value would make the denominator equal to 0? Start that question, because that could give you a weird denominator. We'll get to some of those later. So what would make this equal to 0? Well, all you have to do is set denominator equal to 0. Write that down. Set the denominator equal to 0. So in this case, 5x minus 2 equals 0. Solve for x. So 5x equals, move the 2 over, 5x equals 2. Lastly, divide by 5. X equals 2/5. What if x was 2/5? What if I put 2/5 right here? 5 times 2/5 is 2. 2 minus 2, 0. 2/5 makes this whole denominator equal 0, which means x cannot equal 2/5. So what can't x equal? Let's put all this together. X can't be 0 because it would make this 0. X could be anything here. X can't be 2/5. So what is your domain then? All real numbers except 0 and 2/5. Write that down somewhere. All real except 0 and 2/5 is your domain. Star that right there. Hopefully your work is nice and neat, so you understand what we did here. Okay, so here's the deal. If you have a denominator, please set it equal to 0 so you can find out what x is, what values of x make it equal to 0, so you can exclude them in the end. Okay, so there you go. There's example number 5. To end it off, here's 2 quick examples. Just get some practice for domain. Alright, so here's my f, 2x at 3/4. Here's my g, 2x minus 3. Let's say we did f of g or g of f, and we come down to like 2x 3/4 divided by let's just say f divided by g, 2x minus 3. Okay, so individually you do the domain of this, which is everything except negative, right? Because of the fourth root right here. You can't have the fourth root of a negative number, so it can't. X off to the side, you might want to say, okay, x cannot equal a negative. Okay. Anything else? X could be 0 here. X could be positive. We're good. Okay. Let's do this one. Just by itself, I mean, x could be anything. X could be positive, negative, 0, doesn't matter. By itself. Okay, so all real numbers. So put them together. Basically, you have all the real minus all the negative, because it can't be negative. So we have basically starting from 0 on. So basically, all non-negative numbers are the answer just to this. But keep in mind, it came out to be a fraction, so the denominator of a fraction cannot equal 0. So all you have to do is say, okay, 2x minus 3, you set it equal to 0, and you got 2x equals 3, move it over, x equals divided by 2, x equals 3, 3 halves. What does that mean? X equals 3 halves. If I put 3 halves right here, it would make the whole denominator equal to 0. This cannot happen, which means you can't have negative or 3 halves as an answer. So far we had x cannot be negative and x cannot be 3 halves, which means what's left over. So it can't be 3 halves, which on this number line we can just say it's right there. Can't be this. So basically what we have is x is greater or equal to 0 except, just in the end, just put except 3 halves. There's a domain right there. Or you could say all non-negative except 3 halves. Okay, that's the same thing as this right here. Okay, last question. Erase this. Find the domain. Let's just say, f divided by g again. 3x to the negative 1 divided by x squared minus 4. By itself, if I said find domain, by itself, this means 3 over x. Be careful with that. So x cannot be 0. Off to the side, x cannot equal 0. X could be everything else. Positive, negative, doesn't matter. Down here, by itself, I mean, I could put anything in for x. 0, negative numbers, positive numbers, and that's all real for the second one. But if I said like f divided by g, or if I composed and I got something like this, what do you get? You get x. To simplify, put that down low. 3 up top. X goes down low. X squared minus 4. That looks a little weird, but we can't have the denominator equal to 0. What would make the denominator equal to 0 if x was 0? What else would make the denominator 0? If x right here was what numbers? Now you can figure out in your head, or just set this. I told you, set that equal to x squared minus 4. Set it equal to 0 and you'll find out what makes it 0. So x squared equals, put this over 4, square root, x equals plus or minus 2. So x can't be plus or minus 2, or it would make it all 0. X can't be 0, or it would make it 0. So basically it's every number, all real numbers except these things. That's what you have to write down. So I don't have much room, so I'll just write all real numbers except, you can list them, 0, plus, minus 2. There's your domain. Get good at finding domain. You're going to see those questions again. Good luck. Have a good day.